Welcome. So we're going to do a little review, and just a little review of, first of all, of tables, being able to find derivatives using rules, and then we're also going to look at higher derivatives. Suppose u and v are functions that are differentiable at x equals 3, and that u of 3 equals 5, u prime of 3 equals negative 7, v of 3 equals 1, and v prime of 3 equals 4. Find the following at x equals 3. All right, so if we want to find the derivative of a product, we're going to have to use the product rule. Make sure you never just multiply derivatives, right? The derivative of a product is not the product of derivatives, but rather it's the product rule. All right, so we want to take the derivative of u times v, so that's going to be u times v prime plus v times u prime. And we have all the values we need in the table, so the work is pretty easy on this. All right, so u of 3 is 5. So we have 5 times 4 plus 1 times negative 7. All right, so it's the first times the derivative of the second plus the second times the derivative of the first. And we have all the information right up there in the table. All right, so that would be 20 minus 7, or 13. All right, that would be the derivative when x is 3 for the product u times v. All right, so now how about what if we had a quotient? All right, so we know that if we have a function that's a quotient of functions, we're going to use the quotient rule. All right, so the derivative of u divided by v is going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. All right, so we have all the values we need. All right, so the denominator, when the value of the function when x is 3 is going to be 1, times the derivative of the numerator, that's going to be negative 7, minus the numerator, which is 5, times the derivative of the denominator, which is 4, all over the denominator squared. So v of 3 is 1, so we have 1 squared. So that's going to be negative 7 minus 20 divided by 1. That's negative 27. And let's look at the last one. All right, so here again we have a product. All right. This time it's reversed. All right, so it's v is the numerator and u is the denominator. All right, so we have the denominator, which is now u. All right, so u of 3 is 5 times the derivative of the numerator. So now the numerator is v. All right, so that's going to be 4 minus the derivative of the denominator. So the derivative of the denominator, the numerator times the derivative of the denominator. They're mixing me up, I think, with the v's and the u's. All right, so our numerator is now v, so v is 1. And the derivative of the denominator, that's the derivative of u, so that's going to be u prime, which is negative 7. All over the denominator squared, and the denominator is now u, so that's going to be 5 squared. There we go. All right, so that's going to be 20 plus 7 divided by 25. So the derivative for the quotient v divided by u is 27/25. There we go. And if you have any questions, let me know. Let's look at some higher derivatives. And that's what we're going to be looking at in this particular lesson. So this is going to be a little bit of a short lesson. I think it's going to be a short lesson. So higher order derivatives. So y prime is dy dx is the first derivative of y with respect to x. And it is important that you understand terminology, right? So make sure this makes sense to you. All right, so y double prime, it starts to get a little busy there, right? So that's, well, the prime's there. So this is the derivative of the derivative, right? So we are taking the derivative of the derivative. So we have now dy prime, the derivative of y with respect to x. So essentially, that d dx, that just means take the derivative. So we're taking all this part here means is we are taking the derivative of the first derivative. Oh, I have it right up there. All right, so that's taking the derivative of the first derivative, which is the second derivative, 2 dy dx2. When you see that notation, it means take the second derivative, or find the second derivative. All right, so if we have y double prime, I hate when they use prime mark, too many prime marks, because it gets really hard to see how many prime marks there are when the writing is small. But y prime 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 is the second derivative of dy dx. Right? See, dy dx is the first derivative. So it's the derivative of the second derivative, which is the third derivative, d3y dx3. Right? So if you're told to find d3y over dx3, it means find the third derivative. And now we have y4, because it's so many prime marks, we can't even make another prime mark. We're taking the derivative of the third derivative, which is the fourth derivative, d4y over dx4. And we're going to be taking first derivatives and second derivatives, and maybe sometimes third derivatives, right? When we do some applied problems involving position and velocity and acceleration. But let's just learn how to take some second and third and fourth derivatives, and we're going to be dealing pretty much with polynomial and rational functions in this lesson. All right, so we have f of x equals 2x cubed minus 3x squared plus 5. We want to find d2y dx2, which means we're going to find the second derivative. Oops, sorry. First we got to find the first derivative. All right, so if we're finding the second derivative, first we got to find the first derivative. Let me write dy dx first. I got so excited I wanted to take the second derivative. But you can't take the second derivative until you take the first derivative. All right, so our first derivative, using the power rule, 3 times 2, that's going to be 6x, reduce that exponent by 1, 6x squared, minus 2 times 3 is going to be 6, reduce the exponent by 1. The derivative of the constant is 0. Now we're going to take the second derivative, and this one is a really easy first example. All right, so the derivative of 6x squared would be 12x, and the derivative of negative 6x would be negative 6. That's all there is to that one, right? And if we took the third derivative, all we would have left is a 12. And we couldn't even take the, well, we could take the fourth derivative, but it's 0. Let's try this one. We want to take the third derivative. Well, to take the third derivative, you got to take the first derivative. So dy dx. And I also could write f prime of x, but I really didn't want to write f double prime and then f triple prime of x. So we're going to switch and use the Leibniz notation and use dy dx for this particular example, these particular examples. All right, so the derivative of 2x cubed is going to be 6x squared. We had that one, I think, in the last problem. The derivative of 3x squared is going to be 6x. The derivative of 2x, that's just 2. Now we want the second derivative, d2y dx2. So we're taking the derivative of y for a second time with respect to x. Derivative of 6x squared would be 12x, and the derivative of the negative 6x would be negative 6. The derivative of the 2 is 0. Oh, and I guess I gave this one away when we were looking at the last one because we are taking the derivative of 12x minus 6, what we had on the last page. Well, the derivative of 12x is just 12, and then we're done. Because the derivative of the negative 6 is 0. Let's try another one. All right, so here we want to take the fourth derivative, a little bit harder, and we have a little bit harder function, because the first thing we have to do is change that, those radicals to be exponents. So f of x equals negative 2/5 x to the, oh, excuse me, that's not a 5 in front, that's a fifth root. I misread that. So negative 2x to the 4/5 power. Plus 3x to the negative 2 power minus 12. So now we can take the first derivative, dy dx. All right, so using the power rule, that's going to be negative 2 times, I'll put in parentheses, times 4/5 x to the, all right, so I'm going to subtract 5/5, so that's going to be to the negative 1/5 power. And then we have move the negative 2 in front. So negative 2 times 3 would be negative 6. And we're going to reduce the exponent by 1. So negative 6x to the negative 3 power. The derivative of the negative 12 is 0. Now let's take the second derivative. d2y dx2. Oops, I'm sorry, I didn't finish simplifying. Oh, shame on me. So dy dx equals, and I'm not going to simplify the negative exponents. That would be kind of silly because we still have 2 more derivatives to take. So this would be negative 8/5 x to the negative 1/5 power minus 6x to the negative 3rd power. All right, we've got to take the derivative again. So now we have d2y dx2 equals, so we have the negative 8/5 times negative 1/5, and that's going to be x to the, so negative 1/5 minus another 5/5, that's going to be to the negative 6/5 power. And then we'll have negative 3 times 6 times negative 6, that's going to be a positive 18x, and reduce the exponent again to the negative 4th power. So let's simplify that. So that's going to be 8/25 x to the negative 6/5 power plus 18x to the negative 4th power. And we got to do the next one. All right, let's take the third derivative. So we're going to have 8/25, I'm going to have a lot of multiplying to do here, times negative 6/5, and that's going to be x to the now negative 11/5, because we got to subtract another 5/5, and then minus, so 18 times 4, that's going to be 72x to the negative 5th power. We'll simplify this, and I'm going to have to do the fourth derivative over there. All right, so d3y over dx3 is going to equal negative 48 125 x to the negative 11/5 power minus 72x to the negative 5th. I'm glad I only have one more to do. All right, so finally, d4y dx4. All right, so let's see, 48 times negative 11. So we get, I'm going to write that down. So we have negative 48 125 times negative 11/5 x to the, subtract another 5, that's going to be negative 16/5 power. And that's going to be plus 72 times 5 is going to be 360. Right? 350 plus 10. Yeah, 360. There we go. X to the negative 6. All right, let's simplify this. So d4y over dx4 equals, so that's going to be 480 plus another 48. So that's going to be 548. So positive 548 625. Maybe I should grab a calculator just to make sure. So I did that in my head pretty quick. All right, so 48 times 11. Yep, 528. Added too many in there, holding it in my head. So 528 6/25. And we may as well simplify the negative exponent now. So that's 528 in the numerator, 6/25 x to the 16/5 power, and then plus 360, and in the denominator, x to the 6th power. And there we go. There's the fourth derivative. So if we've got radicals or rational exponents, notice they don't go away. They just get more negative. But if these were just a polynomial, then they get really easy when we take higher derivatives. All right, let's see. This one's only the second derivative. That's not so bad. All right, let's rewrite it first of all. F of x equals x to the 5/4 power plus 4x to the negative 1 plus 11x. All right, so the first derivative, dy dx equals 5/4 x. All right, so we're going to subtract. So 5/4 minus 4/4, that'd be 1/4. And then minus 4x to the negative 2 power plus 11. Now let's take the second derivative. d2y over dx2. So 5/4 times 1/4, that I can do in my head. That's going to be 5/16 x. 1/4 minus 4/4 is going to be negative 3/4 power plus 8x to the negative 3 power. And the 11 is now gone. So let's simplify this. d2y over dx2 equals, we've got 5 in the numerator and 16x to the 3/4 power in the denominator, plus 8 in the numerator and x cubed in the denominator. So hopefully these aren't too bad. I'm going kind of quick, but I think you probably are going to get it right away. It's just kind of a review. I think I've got maybe 2 or 3 more. All right, third derivative. All right, so we have f of x equals x to the 2/3 power plus x to the negative 5 power. At least we have small, we don't have big coefficients in front. All right, so dy dx equals 2/3 x to the negative 1/3 power, right, because we would subtract 2/3 minus 3/3, minus 5x to the negative 6 power. Let's take the second derivative, d2y over dx2. So now we've got 2/3 times negative 1/3, that's going to be negative 2/9, x, and then negative 1/3 minus another 3/3 is going to be negative 4/3 power, plus, because we got negative 5 times negative 6 is going to be plus 30x to the negative 7 power. And one more time, d3y over dx3. So this time I can do it in my head, I guess. So negative 2/9 times negative 4/3 is going to be a positive 8/27. X to the, so now we've got negative 4/3 minus another 3/3, that's going to be negative 7/3 power. And minus negative 7 times 30, that's minus 210 x to the negative 8 power. Let's simplify that. So d3y over dx3 is 8 in the numerator, 27x to the 7/3 power in the denominator, and then minus 210 in the numerator, x to the 8th in the denominator, and another is done. Let's do a couple more. Let's see how many more we have. I have 1. Is that the last one? Except it's the fourth derivative. Yep, that's the last one. So one more. So this is that. The other stuff is just a review of chain rule, and we've already done it. Let's do one more problem. First derivative, and I need to simplify that. So y equals 19x to the 7th plus 5x to the negative 1. dy dx equals, the bad thing is the coefficients. I had to make it 19, didn't I? So that would be 70 plus 63. That's going to be 133. X to the 6 minus 5x to the negative 2 power. And I do have a calculator here just in case, because after a while these numbers are going to get really big and I don't necessarily want to sit here and do all of them in my head. So I'm just going to double check that one. Whoops! I am going too fast. All right, so 70 plus, what did I say? 70 plus 63. Oh, I typed in the wrong thing. Never mind. It's definitely wrong if I type in the wrong number. No, I had that right, 133. All right, so calculators are only as good as how well you type into them, apparently, right? I'm using a lousy little calculator, too. All right, so d2y over dx2, 133 times 6, 798. In the interest of time, I'll just use a calculator. 798x to the 5th power plus plus 10, right? 5 times negative 2, plus 10x to the negative 3 power. All right? d3y over dx3 is 798 times 5. It's going to give us 3,990 x to the 4th power minus 30 x to the negative 4 power. There's track there. And then one more. d4y over dx4 is 15,960 x to the 3rd power plus 120x to the negative 5 power. Let's simplify that. So finally, d4y over dx4 is 15,960x cubed plus 120 in the numerator and x to the 5th in the denominator. And there we go. There is our 4th derivative. All right, so I hope you enjoyed this little review of higher derivatives, and I'll see you in the next podcast. Bye for now.